Hey guys, this is our first ever video. I grabbed, this is for MCV4 use. This is a calculus course in Ontario, grade 12 calculus, but it could be applied, over any province or even into the States. Calculus grade 12. So I took a document from LA-Citadel, so you can check it out, and it's a final review. So I figured I would do these final review questions. I'm using Zernal on Linux. And so yeah, let's start by evaluating limits. So that's going to be the first test here for Lehigh. So we've got part A, and we're finding the limit as x approaches -2 of f of x. So they give us a nice graph, and we have to evaluate the limit of this graph at x as x approaches -2. So essentially what that translates to is look at the y value as you're approaching -2 from the left and the right. If you approach the same y value, then the limit is that y value. So if you're approaching -2 from the left, I've got a y value of 1. From the right, I've got a y value of 1, so the limit becomes 1. Part B, limit as x approaches -1, f of x equals. Now for -1, we've got an issue. There's a discontinuity. And we've got, from the left, a y value of 2. From the right, we've got a y value of -1. So in that case, what we end up saying is that the limit does not exist. D and E. Next, we've got limit as x approaches 1 of f of x. These are basic evaluations of limits from plots, from graphs. Okay, so as x approaches 1 from the left, the y value is 3. And from the right, the y value is also 3. So in that case, we say that the limit is 3. Notice we didn't take the actual value of the function at x equal 1, rather the limit as we follow the curve, right? So those are different things. Here we say we have a discontinuity as well. Limit as x approaches 3, right? 3 of f of x. Now, same thing. So from the left, we get a y value of 1. From the right, we got a y value of 1. So we say our limit is 1. So that's a basic evaluation of limits. Now we make it a little harder. We've got actual functions, right? So here we had a general f of x and we had a plot, right? Here we have actual functions. Now, when you're evaluating a polynomial, okay, generally what you can do is you can just plug in, right? You could just do direct substitution. Only in cases where you have 0 over 0 after a direct substitution do you have to do something more, and we'll actually get into that. So for this case, we've just got -1 cubed, okay, minus 2, -1 squared, plus 3 times -1 minus 1. Now, -1 cubed is just -1, so I'm just going to replace that by -1. Okay. -1 squared is just 1, so -2 times 1 is just -2. This guy becomes -3, so I'm just going to put -3 because a plus and a minus make a minus. And we've got -1. So we've got -1 minus 2 minus 3 is -6, minus 1, -7. So the answer to the first question is -7. So I'm going to erase this, and I'm going to proceed to the next part. So part B. Okay. So it's not too shabby. Always, before you evaluate these kinds of limits, always check if you can do direct substitution. If you can do direct substitution, great. Okay, so if you don't get 0 over 0, you're fine. Okay. Let's see. So if I do a direct substitution, I get 2 plus 2 squared, right, over 2 cubed minus 2. So I don't get zeros anywhere. So I can do a direct substitution. So I go 2 plus 2 squared, 2 plus, well, 2 squared is 4, 2 plus 4 is 6. So I get 6 on the bottom. On the top. On the bottom, I get 2 cubed, that's 8. 8 minus 2 is also 6. So in the end, I get a value of 1. So that's the answer to part B. And note, if I make any mistakes, just let me know in the comments section, and I'll look into it and I'll make a correction in the next video, or in the comments, or in annotations, or something like that. So let me know. That would actually help me out a lot. So the limit as x approaches pi over 2 of the square root of sine x. Now in this case, right, I can also do a direct substitution. So I need to know what sine of pi over 2 is. So sine of pi over 2 is 1. So really, this is just the square root of 1, so I end up getting 1 again. So far, I think I've been getting, initially I got, what, -7, 1, and 1 now? So, let's see. So part D, and it's the limit as x approaches pi of 2 to the cos x. Now, if I plug in pi into x, right, I end up just getting cosine of pi, 2 to the cosine of pi. Cosine of pi is -1. So I end up getting 2 to the -1, which can be rewritten as 1 over 2, because that -1 means I can drop the 2 down to the bottom, and there always has to be a numerator of 1 at least, so you got 1 over 2. Okay, and that's that. So I've got my answer to 2 all done. Now I'm going to do these kind of piecewise functions. Okay. Now, part A, it wants the limit of f of x. It says f of t, and actually there's a little bit of a mistake here. This should say exist, if they exist, okay, and find the following limits. So these should all be x, don't worry. So we need to approach -1, f of x. Okay, let's see. So this deals with f of x to the left of -1. That's the function. That's why we have x less than -1. This deals with function f of x to the right of -1. So what we have to do is we have to evaluate both the limit from the left, right? That's what this extra minus means, and limit from the right, f of x. So all I can do is take this, all I need to do is take this function, okay, and I plug in -1, and I end up getting 0 for this guy. Here, I end up getting the square of -1, which is 1. Now, these two are different. These are one-sided limits that don't equal each other. One is not equal to 0. So that is a similar situation to this guy. I had a discontinuity. So I say that the limit does not exist, just as I did in part B of question 1. So this guy, D and E, okay? Now I got to figure out this one. So I'm going to erase this. Once you get the hang of these kind of functions, it's just a breeze. It's just a breeze. Okay, so x approaches 0, right? So again, we probably... no, actually for 0, we don't have to really evaluate one-sided limits because we just have one function in play. 0 is in between, right? So we just have one function in play. It's not a boundary value. So the limit as x approaches 0 would just be 0 squared, so we get 0. So the answer here is 0. Ah, that looks like a 6. I apologize. 0. Okay. And now for 1, for an x value of 1, we again have to evaluate one-sided limits. Okay, so we're going to do 1 from the left and limit as x approaches 1 from the right. And it's going to be of f of x. F of x. Okay, so from the left, I got to use this function, x squared, right? So I got to do 1 squared, and that's 1. From the right, I do square root of 1, and I get 1. So both are equal, so that is the limit value. It is 1. Ah, I apologize. I'm just getting used to using this graphics tablet. It is 1. So now we're going to do some examples on evaluating limits that don't involve direct substitution. We actually have to do some work here. I'm just going to do one example in this case, and I think I'm going to continue later on since this is just a first video. So I'm going to show you what I mean by not being able to directly substitute. So if I look at A, I've got a limit as x approaches -2. And I've got x squared minus 4, okay, all over x plus 2. If I do a direct substitution, I got the square of -2. That's 4. So I end up getting 4 minus 4. That's 0. And I get -2 plus 2. Okay, so I end up getting 0 over 0. No bueno, that's indeterminate. Okay, so I have to actually do some work here. Now, when you've got like a rational function, a polynomial over a polynomial, chances are what you can do is you can actually, I don't know why I'm erasing this right now, chances are what you can actually do is you can factor stuff out, either out of the top and bottom, and you can cancel. So here we have what is called on the top, it's called a difference of squares, right? So we can do x plus 2, x minus 2, okay? So that's the classic, a squared minus b squared equals a minus b times a plus b. Okay, classic. So I use that here, and notice now we've got a whole factor that can just go away. And we've got x minus 2, right? And I don't want to forget my limit, okay, as x approaches -2. So really, at this point, I've got a polynomial. So I've got the same situation that I had just a couple of questions ago. Let me go to it. This situation, it's polynomial. So I can do a direct substitution now. And when I do a direct substitution, I get -2 minus -2. That, in the end, is -4. That's the first part, and I'm going to continue on with the later video. Thank you so much for watching. If you can, please subscribe to our video and keep us up and running. Thank you so much, and subscribe to our channel, and yeah, thanks for watching. Bye.